Systems of linear and quadratic equations. Let's look at an example of a system that contains both a quadratic and a linear equation. Here we have y equals the opposite of x squared minus x plus 6, and y equals x plus 3. Our first equation is quadratic, our second equation is linear. And we're specifically going to learn to solve this system algebraically. Now, since both of our equations in our system are solved for y is by itself, we can use substitution, just like you learned to use when you were solving a system of two linear equations in two variables. So we will substitute x plus 3 for y in the first equation. So I can write x plus 3 equals the opposite of x squared minus x plus 6. Now we'll write this in standard form. So I'll add x squared to both sides of my equation, I'll add x, and I'll subtract 6 to both sides. And I'll end up with x squared plus 2x minus 3 equals 0. So that's now a quadratic equation in standard form. Third step, let's factor and solve for x. Or you could also use the quadratic formula to solve for x. Or completing the square. So this does factor, so we'll factor it. And we're looking for numbers that multiply to negative 3 and add to positive 2. These will be positive 3 and negative 1, because 3 times negative 1 is negative 3, but 3 plus negative 1 is 2. Now we'll use the zero product property and set each factor equal to 0. So x plus 3 equals 0, or x minus 1 equals 0. And we'll solve for x. In the first equation, I'll subtract 3 from both sides, and I end up with x equals negative 3. In my second equation, I'll add 1 to both sides, and I end up with x equals 1. So x equals negative 3, or x equals 1. Now, we'll find y by substituting for x in y equals x plus 3. I could substitute into the first equation as well. I just figured the linear equation was simpler to substitute into. So we have to do this for each x value. So let's do this for x equals negative 3 first. So y equals x plus 3 is what we're substituting into. So y equals negative 3 plus 3, or y equals 0. That means when x is negative 3, y is 0, so I have the coordinate negative 3, 0. Now let's do this for x equals 1. So we'll substitute x equals 1 into y equals x plus 3, y equals 1 plus 3, or y equals 4. So when x equals 1, y equals 4. And that is my second ordered pair that is my solution to this system. So these are my two solutions. We should, of course, check our solutions, and we can do this by substituting the values into both of the original equations and making sure that the values make both original equations true. So we'll do this for negative 3, 0 first. So we'll substitute first into our quadratic equation, y equals the opposite of x squared minus x plus 6. Remember, the ordered pair means x is negative 3 and y is 0. So substituting in, we're testing whether 0 equals the opposite of negative 3 quantity squared minus negative 3 plus 6. Simplifying, does 0 equal negative 9 plus 3 plus 6? Does 0 equal 0? Yes, it does. So it satisfies the first equation. Now let's see if it satisfies the second equation, y equals x plus 3. Substituting in, does 0 equal negative 3 plus 3? 0 does equal 0, so yes, it does satisfy the second equation as well. Now we'll check our solution 1, 4. So here x is 1, y is 4. We'll substitute into our first equation, y equals the opposite of x squared minus x plus 6. So does 4 equal the opposite of does 4 equal the opposite of 1 quantity squared minus 1 plus 6? Simplifying, does 4 equal negative 1 minus 1 plus 6? Does 4 equal 4? Yes, it does. So 1 comma 4 satisfies the first equation. Now let's check it in our second equation, y equals x plus 3. Substituting in, does 4 equal 1 plus 3? 4 does equal 4, so yes, it satisfies the second equation as well. And both of these solutions are solutions to our system. So we have two solutions to our system.